Hello, my name is John Harris, and this is my action plan for improving graphing of parent functions. The problem of practice is teaching of graphing parent functions to students in pre-calculus who struggle with the rules of transformation. This pre-calculus class consists of grade level seniors, 1 level accelerated juniors, and 2 level accelerated sophomores. Parent functions are our basic functions that they cover in Algebra 1, Algebra 2, and again in pre-calc. And those functions consist of linear equations, which are just a line, quadratic equations, which create a U-shape, cubic functions, which is an S-shape, square root functions, exponential functions, and absolute functions. This is going to create the groundwork for when they deal with more complex functions such as logarithmic, trigonomic, and dealing with sine, cosine, tangent, and then how to graph those in not only degrees but in radians. And then the transformations that they'll be working with are translations, which are shifts in the graph. It can be a vertical shift, which moves the graph up and down. It can be a horizontal shift, which moves the graph left and right. Dilations are stretches or compressions. It can be stretched or compressed vertically, and the graph can be stretched or compressed horizontally. And finally, we have reflections, which is the final transformation. Reflections are flips in the graph, and they reflect over either lines or axes. It can be the x-axis, which is going to flip the graph vertically. It can be flipped over the y-axis, which is going to flip the graph horizontally, or it can be reflected over the line y equals x or the line y equals negative x. As we can see from figure 1, this is my grade level assessment scores. This was for the chapter of graphs. We can see based off of formative 1, formative 2, and my summative assessment that students on average did worse on formative 2 compared to formative 1 and the summative assessment. Formative 2 focused on identifying and applying transformations to these parent functions. It didn't matter if the student was grade level appropriate as a senior, if they were 1 level accelerated as a junior, or 2 level accelerated as a sophomore. They still very much struggled with this assessment. If we look at my figure 2, it's my formative 2 data, and this is comparing the scores from this school year in 2023 to last school year of 2022. Not much changed. The data is very, very similar. But if we look closely at the data, students actually did worse this year as compared to last year. This year, 5 students scored below 40%, and last year only 3 students scored below 60%. So what we're doing isn't working, and we need a change. The current research, Ferguson discusses that the points on the transform graph may not be obvious compared to the parent graph. For example, a horizontal stretch may look like a vertical compression to some students. And if we look at this table right here, it just shows all the rules for how to change a point algebraically, and this can be very overwhelming for students. And students do not understand the impact one transformation has on a graph and the value of the points. Lebowski talks about how students can lose sight on what the graphs are supposed to look like when combining 2 or more transformations onto a function. For example, a quadratic function creates a U-shape or a parabola. If there are multiple transformations going on, such as a reflection or a shift, They may draw, instead of a U, may draw a C because they think a reflection is rotating the graph rather than shifting and reflecting the graph. When we were addressing the problem, Kenny suggests that using a TI calculator, graphing calculator, is a way to aid students to model mathematical situations. Students who have a calculator available to them, they wind up feeling more comfortable with themselves, and math is such a math is such a confidence thing. If you feel more comfortable and confident with yourself and your skills, you're going to wind up doing better. I would recommend using the TI-84 calculator as opposed to the TI-83 calculator. The TI-84 calculator is newer. You can do it, you can have it in color. It's faster, you can put more programs on it. And the TI-83 calculator is honestly just a little bit older. It's a little bit slower. It's hard to see in black and white. It's a lot more pixelated. The TI-84 runs a lot smoother. Kaglian also suggests the use of visualization. Visualization is not only used to solve problems, but also to see patterns. And technology tools such as GeoGebra, Desmos, and using those TI graphing calculators provide 8 different uses: gaining insight, finding new patterns, graphing to understand principles, testing thoughts, exploration, suggestions, replacement of handwritten problems, and confirmation. Both of these programs are free. Everybody loves free. We are a one-to-one district. The students all have graphing, all have their Chromebooks and have these available to them as well. Desmos is actually going to be used on the SAT. The SAT is going digital this year, and students have the ability to use Desmos on their Chromebooks. When we're addressing the problem, Ferguson suggests plotting one transformation at a time onto the new function. For example, if there's a function where we have a vertical shift, a reflection, and also a compression, he suggests first shifting the graph up, and then from our new graph, he suggests then using reflection. From our second graph that we've made, we can then do a translation. So we are doing the graph 3 different times and plotting these points 3 different times. Ferguson also suggests a method called rescaling the axis, which is a very interesting approach. Instead of transforming the points, we're actually going to apply the transformations on the axes themselves. We're not touching the actual points at all. When we do this, the shape of the graph is going to look exactly the same as the parent function, but instead our units on our axes are going to be changed. When we look at our instructional strategies, drawing each transformation by hand and algebraically transforming the problems, it has a low to medium impact and a medium feasibility. It is going to be very time consuming for the students to graph each function individually or each transformation individually. And honestly, I think it's going to be more time consuming and more trouble than what it's worth. I know that students can plot points. I'm more concerned with them understanding the pattern that's going on. Rescaling the axis kind of has more of an impact than drawing each transformation by hand and has a medium feasibility. It does come down to time. It is going to be time consuming, and students, I think it's going to be a completely different way of thinking, and I think students are going to have a difficult time with that. The last two are using the graphing calculators to compare transformation, as well as using graphing websites or software to compare transformations. Both have high impact, both have high feasibility. But overall, I think that using the graphing calculators to compare transformations is best. Every student is required to have one, and they are familiar with how to input functions create graphs, draw graphs, pull up points, create tables, um, finding a value at a certain point. They know how to do all of this already in their calculator. We are not going to have to reteach them how to do it, as opposed to reteaching them how to use a new software. And ultimately, I believe that this is going to set them up for success in the future. When they get to calculus or when they take math at a college level, they aren't going to be able to have a Chromebook or a tablet or access the internet with those assessments. What they will have is their graphing calculator, which they are able to use. We want them to be set up for the future, not just this class. Our implementation indicators. Our students are going to know what the word translation, dilation, and reflection mean, our transformation words, and accurately use them. They're going to be able to answer questions that show their ability to transform parent functions, and they will ask peers and teachers for clarification. In the classroom, there is going to be evidence of students transforming a graph. There's also going to be directions for how to get to certain things in their calculator. And there will be flexible seating for students to work with others or if they want to work by themselves. As far as for student work, they are going to demonstrate students' ability to describe graphs and create equations of parent functions and their transformations. In Figure 5, we can see the action plan for teaching transformations with our graphing calculators. At the beginning of the school year, the pre-calculus teachers are going to find webinars on TI calculators. In September, the pre-calculus teachers will find professional development on these TI calculators to learn how to use different software and find different applications they can use. In the rest of September and mid-October, the teachers in the math department are going to teach strategies in class for how to use the calculators. The earlier we can get these students to use the calculators, the better. From October to mid-November, the teachers in the math department will visit one another's classroom and provide feedback to each other. And then finally, November to December, the pre-calculus teachers will use the strategies using the graphing calculators to assist finding patterns in the transformations. It's going to be done by mid-December because that is when the unit is and right before final exams. For the evaluation, we're going to measure the grades of Formative 2 of students who did work with their calculators as opposed to the last 2 years when they did not use their calculators. We will also measure the impact this program made on their final exams. A lot of times students will want to know the steps rather than understand the concepts. And we're also going to measure the current juniors and sophomores when they take calculus next year to see if it had an impact from the calculus students this current year. Here are my references. If you have any questions, please feel free to contact me via email. Here's my email. Thank you very much for listening, and I hope you take this into consideration. Thank you.